Okay, welcome back everyone. As promised, I'm going to go over the harmonic oscillator. Please try to follow with me because it's going to be just a one long thing. All of it is connected to each other. So try not to lose the train of thought, okay? So the potential for the harmonic oscillator, you remember omega is the square root of k over m. And so k will equal to m times omega squared. The potential for a simple harmonic oscillator is 1/2 kx squared, and that's 1/2 m omega squared times x squared. And we're going to place this right into the Schrodinger equation, which says minus h bar squared over 2m, second derivative with respect to x, psi, plus u times psi, but here is u. U times psi, that's 1/2 m omega squared x squared times psi. Any questions about what this is? That's the left side with Schrodinger equation. What's the right side? Equals to e times psi. E times psi. Now, this thing here we can place psi to the right. I can write this way. This equation in the following way. Now this psi, if you bring it in, you just, when the second derivative multiplies psi, that's the second derivative. This thing here is called H, or the Hamiltonian. I mentioned it before. It's basically the total energy. The potential energy, this is the kinetic energy. Right? Because momentum is I h bar, or minus I h bar d dx. When you square it, you get minus h bar squared, second derivative with respect to x. And then over 2m. P squared over 2m is the kinetic energy plus the potential energy. Okay. So in other words, Schrodinger equation can be written as H psi equals to E times psi, where H stands for this entire thing. Okay. So our goal is to solve this equation. The problem is, you can solve it analytically, takes a while. You can solve it also algebraically and cleverly. It takes actually less calculus. It's called the algebraic method, or the algebraic way of solving this. But it does involve some calculus, not entirely algebra. So I'm going to first mention the following thing called the commutator. For example, if I have the commutator of A and B, this is the notation, square brackets A comma B. It's defined as A times B minus B times A. And you might think, A times B minus B times A, how much should it be? 0, right? In general, yeah, I mean, with real numbers, yes. But imagine A and B are matrices. Matrix A times matrix B, generally speaking, is not the same as matrix B times A. Okay? They're generally not commutable. Okay. So let's try this with the position and momentum operators, X and P. And let me put a function psi here to help us figure out what X and P is. It's going to be x p times psi minus p times x times psi. Okay, so that's equal to x. Remember what p is? It's minus I h bar d dx times psi, and then minus p is minus I h bar d dx of x times psi. I should have allowed myself a little more room than this, but let's see if we can do it here. So here I have minus I h bar, that's just a constant, and then x times d psi dx. Right, this is d psi dx. And then minus minus is plus I h bar. Now you have d dx of x times psi. You have to apply the product rule. Derivative of the first times the second plus the first times the derivative of the second. So what's the derivative of x with respect to x? Just 1, right? So we just have psi. And then plus I h bar, derivative of, x, and then times the derivative of psi with respect to x. You notice that this and this cancel. Okay, so what remains is this I h bar psi. So let me summarize what we obtained. Let me summarize it. So we got this. X and p times psi is equal to I h bar times psi. That means just x p is equal to I h bar. Okay. So now this basically is not related to what we're doing, but I just wanted to go through this commutator. So now we're going to define the following two operators. One of them is called the raising operator. The other one is the lowering operator. And you will see why they're called raising and lowering in a moment. Does this look okay, or is the writing big enough, or is it too small? Okay. All right. So here's what we're going to define. This a plus will equal to 1 over 2m h bar omega square root times minus h bar d dx plus m omega times x. That's a plus. And then a minus, which is, and you'll see why we're defining them. For now, you can define whatever you like, right? And we're going to use them and see where they take us. 2m h bar omega, and then h bar d dx plus m omega times x. Notice the only difference between a plus and a plus has a minus sign here, and a minus does not. Otherwise, they're identical. And it's that minus sign that differentiates them. So the plus has a minus sign, the minus does not. So, by the way, this is outlined in homework 11. So I'm going to follow about basically the footsteps of homework 11. And if you want to review it, you can check. As you're doing homework 11, you can refer to this, to your notes. So let's first start here. That's A. Let's figure out what A minus A plus times psi is. Okay. So this will give us, we'll just use the definitions of A minus and A plus. when a minus times a plus, both of them have 1 over the square root. So when you multiply the square roots, it's just the square root goes away. So I just have to follow. 1 over 2m h bar omega. And then I have the a minus first. So I must have this thing first. H bar d dx h bar dx plus m omega times x, and then a plus minus h bar d dx plus m omega times x times psi. And I'm going to, instead of writing another line, I'm going to just modify it right here. What I mean by this is, please look at this and let me know if this is fine first, before I modify it. I'm going to make one modification. Can I get some feedback? Is this okay? Yeah? Okay. So what I'm going to do is just bring psi a. So psi and psi, and no more psi here. Okay. Next step, we're going to FOIL this expression. We're going to FOIL it and see what we get. I think I will allow myself a little more space. So I get, I will allow myself a little more space. 1 over 2m h bar omega. Okay. First term times the first term first. This one times this one. H bar times negative h bar is minus h bar squared. d dx times the derivative of psi becomes what? So the second derivative of psi with respect to x. Next, same term times this. So we get h bar m omega. Here's the thing. d dx is going to operate on both x and psi. So you have to take, you apply the product rule. So the derivative of x is 1. So you just have psi. And then the product rule is not done yet. So you get h bar m omega, and then x, and then d psi dx. Okay? And then we're going to multiply these. We have the minus h bar m omega x d psi dx. This one times this one. M omega x, so that's m squared, omega squared, x squared, psi. Any simplifications that you can see? These, right? One of them is plus, the other is minus. Very cool. And since the other bracket is square, this one should also be square. Okay. Alright, so here we have equals. I'm going to leave 1 over h bar omega on the outside, meaning I will take 1 over 2m inside. So I will have minus h bar squared over 2m, the second derivative of psi with respect to x. Okay. And then here, 1 over 2m. Actually, this one, let me leave this one alone for now. Let me leave this one for a moment. Let me talk about this one first. When I multiply by 1 over 2m for this one of the m's cancel out and I will have a half. So I have plus 1/2 m omega squared x squared times psi. Okay, I close the bracket. Now, plus this one I'm going to take it outside the bracket, so I will multiply it by 1 over 2m h bar omega. So h bar m omega, m h bar omega, they cancel, and I would just have a half of psi. I just have 1/2 of psi. This is a minus a plus psi, a minus a plus psi. So we get a minus plus times psi is equal to 0. This is 1 over h bar omega. Now what is this? Yeah, that's just h times psi, right? It is h times psi. Okay. So that's just h times psi plus 1/2 of psi. So now this, all of them are multiplied from the right by psi. So I can just leave psi alone now. Just remove it. And that means I have the following. I have a minus, a plus is equal to 1 over h bar omega h plus 1/2. Okay. And I can solve for h. So I get h is equal to a minus, a plus times 1/2. And then h bar omega. And I will put this one in the box. One more. The next one will be, we're going to reverse the order and do the same thing. So the next one is we're going to reverse the order and see what we get. Meaning this: a plus, a minus times psi. A plus, a minus times psi. What do you have to do? Well, we can redo the whole thing. Okay. So what changes? So what changes is this. Instead of a minus being here, a minus will be in front. So this will be a plus and this will be a minus. You have a minus sign here and you have a plus sign there. Okay. Does that make sense? Because I don't want to repeat the whole derivation. So what happens? So you just write this step. You have a plus, a minus sign here, a plus sign there, and you will FOIL it. And when you do that, here's what you will get. You will get that a plus, a minus is equal to 1 over h bar omega h psi minus 1/2 of psi. And so, meaning a plus, a minus is equal to 1 over h bar omega h minus 1/2. That's what we got. Any questions how I got this? So I didn't really do the whole math, but this is part B if you like. So we get this. Now, now let me do this next part. A minus, a plus, the commutator. It's a minus, a plus, minus, a plus, a minus, right? That's the definition of this commutator. So look at this. A minus A plus is that. So let me write it down. A minus A plus is 1 over h bar omega capital H minus plus 1/2 minus A plus A minus is here. That's 1 over h bar omega capital H minus a half. So what do we get? This minus this gives 0, and then a half minus minus a half would be a half plus a half, which is 1, right? So this is this. Okay, good. We're inching toward what we really want. Okay. Next step is we want to do this commutator, capital H and A plus. Capital H and A plus. And it seems like actually I might have enough space. So it would be H A plus minus A plus times H, right? Sorry, it might be tedious at first, but I hope you're following. Because I want you to follow to the end. So we're going to substitute what H is. Here's H. Let's just substitute it. So you get H bar. This H has an H bar omega, this one has an H bar omega. So let me just put H bar omega in front of everything. And then we have A minus A plus minus a half times A plus. And then minus A plus, this is the A plus part, times this. A minus A plus minus 1/2. So, and then just open it up, and you have H bar omega times A minus A plus times A plus. So you have A minus A plus A plus. And then minus 1/2 of A plus minus A plus A minus A plus minus 1/2 of A plus. I'm sorry? Oh, minus times minus is a plus. Yes, thank you. And that means, here's the good news, or the good thing. These two cancel. Okay. And this one is A minus A plus times A plus. And this one is A plus A minus times A plus. So both of them have an A plus to the right. So I'm going to factor to the right the A plus. Here's what I mean. Let me write here. H A plus will equal to H bar omega A minus A plus minus A plus A minus and then A plus, right? You agree when I multiply from the right by A plus, I get the same thing, right? So now, what is A minus A plus minus A plus A minus? That is 1, right? Good. Yeah, that's just this commutator here. That's just 1. Yeah, so this is simply equal to 1. Which means H and A plus is equal to H bar omega A plus. Okay. Good. So let's maybe put a box around this one. We're going to do the same thing but with H and A minus. Okay. So the next one is going to be H and A minus h bar omega times h a minus, h times a minus. H will have this, a minus a plus minus a half. Times a minus, minus a minus times this. Please let me know if you have a question. Give you a moment to maybe think about this. Sounds good? Okay. To do this, I'm going to FOIL the expression now. Then h bar omega a minus a plus times a minus minus 1/2 of a minus, and then minus a minus times a minus times a plus, minus times minus is plus, so plus 1/2 of a minus. So similar good thing happens like earlier. So let's see what we get. So notice here I have a minus, a plus, a minus, and then minus, a minus, a minus, a plus. What should I pull out and to what side? To the left, the a minus, right? Yeah. So you get h bar omega a minus. Let's see what's left. A plus, a minus, minus a minus, a plus. Who knows how much this is? Yeah, right. This is -1. Because just for the sake of it, this one was +1, but this one is just downward reversed. Okay? That's -1. So we get, in other words, okay, h and a minus is equal to minus 1 times h bar omega a minus. We have done most of the hard work now. Okay? Now we're going to apply what we have. We're going to apply what we have learned. So just from Schrödinger equation, h psi equals to e psi. So suppose I have a state with energy level n, En. So let's call that state psi n. So h times psi n will have energy En times psi n. By the way, this may look familiar from linear algebra. If you think this is a vector, this is a matrix, a vector times the matrix gives you the vector and then a constant times the vector. What's that equation called? This is the eigenvalue. Yeah, the eigenvalue. Similarly, h times psi n plus 1 is equal to En plus 1 times psi n plus 1. Okay? And let's name, and you will see why the name is appropriate in a moment. Let this psi n plus 1 equal to a plus times psi sub n. Okay? A plus times psi sub n. Meaning, when I apply a plus to psi sub n, I change the subscript by 1. I'm just naming it this way. It doesn't have to be named that way, but it turns out to be the appropriate name. Okay, so the question is, what's the relationship between En plus 1 and En? How are they related? If En, let's say, is something, what would En plus 1 be? What would En plus 1 be? And how would they relate to each other? Okay? So basically this, we said that here, En plus 1 times psi n plus 1 is equal to h times psi of n plus 1. I just wrote this in the opposite order. Okay? This is h, but what is psi of n plus 1? Psi n plus 1 is a plus times psi n. Okay? Psi n plus 1 is a plus psi n. So I have this h psi plus h a plus psi so n is equal to I'm going to use this result here. Maybe I should do some side work. I'm going to use this result, meaning this h a plus minus a plus times h is equal to h bar omega a plus, and so h a plus is equal to a plus times h plus h bar omega a plus. Okay? So I have h a plus. I'm going to replace it by that. Let me distribute psi n through so we can see it more clearly. Now what is hn? H times psi n? H times psi n is what? Is En times psi n, right? H times psi n is En times psi n. Because H times psi n is En times psi n. So I have a plus times En psi squared plus h bar omega a plus times psi sub n. That's h bar omega psi sub n plus 1. So it's a plus psi sub n, a plus psi sub n psi sub n plus 1. So, now En is just a number. En is just a number. I can pull it in front. So I would just have En and then a plus psi sub n. So what is En times a plus psi sub n? That's going to be what? En times psi sub n plus 1, right? Right. So En can be put in front. It's just a constant. It's a number. A plus times psi sub n would be psi sub n plus 1. So meaning I would have this. En psi sub n plus 1 plus h bar omega psi sub n plus 1. And so I get En plus h bar omega times psi sub n plus 1. This is meaning En plus 1 is equal to whatever En is plus an h bar omega. So here's what the final conclusion. En plus 1 is equal to En plus h bar times omega. Now what's the significance of this? Here's what we're saying. If the energy level, the nth energy level is En, the next energy level would rise by h bar omega. So meaning energy levels are spaced by an h bar omega. So if the first one, if one of them is En, if the nth one is some energy E, the next one is going to be h bar omega in addition to that. So it's going to be E plus h bar omega. Next, we're going to do the same thing, but with the lowering. That's why this one, A plus, is called the raising operator. So every time you apply A plus, the energy rises by an h bar omega. Okay? The energy level rises by an h bar omega. A minus is going to be called the lowering operator. It will be called the lowering operator. So very similar. So we're going to go here. So for example, h times size of n minus 1 is equal to e of n minus 1 times size of n minus 1. And size of n minus 1 is defined as a minus times size of n. So we have en minus 1 times size of n minus 1 is equal to h times size of n minus 1. And that's equal to h. But size of n minus 1 is a minus size of n. I'm curious if this is okay. If it's not, please let me know so I can go over some things again. Is it okay? Well, in that case, then I'm going to refer to this result. And it will tell me that h a minus minus a minus h is equal to this. So that means this one is equal to a minus times h minus h bar omega a minus. And that's what I'm going to substitute here. So h a minus, for this h a minus, I'm going to substitute a minus times h minus h bar omega a minus.